All right. Yesterday, you guys were using the reverse power rule, and yeah, that's pretty much all you used, and different strategies to find indefinite integrals, um, and aka general forms of antiderivatives. So today we're going to focus on finding specific solutions for an antiderivative. So let's say we start with this. We have f prime of x is equal to 54x minus 1, and we're told that f of 1 should equal 38. So important is we have the derivative and we know a specific point on the original function. That should be enough for us to figure out what the general, like what the particular solution to this f of x should be based off the additional information of the given point. So if we integrate uh, f prime of x with respect to x, all right, reverse power rule comes into effect. I know I would have had an x squared. So if I do 54 divided by that x, by that 2 from the x squared, I should get a 27. Right? If I end up with a negative 1, that means it would have come from a negative x, and then I do a plus c. So that's what I think f of x should equal. I know that for sure based off what I had for the derivative, but I don't know what the c value is. This is where the extra piece of information comes in. I'm going to go ahead and solve for c. So if this is what I think f of x is, then I know that I have 27 squared minus plus c should equal 38. And now all I do is just go ahead and plug in the 1 in for the x's and the 38 for the output. I can just go ahead and solve. So that's 27 minus 1 plus c equals 38. 26 plus 12. Okay, so c has to equal 12. So that means f of x should be 27x squared minus x plus 12. And that's all you really have to do. Once you find your like the general form of the antiderivative, take the extra coordinate point that they give you, plug that in for, or plug in the number they give you for the x, set that equal to the output, and just use that to solve for c to figure out what the actual equation should have been. On some of these, you might have to do a work from a second derivative to go all the way back to the original problem. Okay? So let's do this. Let's keep the f prime of x. Let's keep the f of 1 equals 38. But instead of finding lowercase f, let's change that to capital F. All right? And I need one more piece of information. So here's the other piece of information we're going to use. Given f of 1 equaled a 17.5. All right. So we have half the work done. The first thing I need to do is I need to figure out what f of x should equal. So based off all the calculations I have, I know that so far f of x should equal this equation. So now we're kind of doing the same thing we just did. We just have to do it one more time now with this larger equation. So let's go ahead and update, right? I need to go ahead and find the derivative, the integral, the indefinite integral of the equation I currently have for f, lowercase f of x. Integrate that one more time in order to find capital f of x. So we have integrate 27x squared minus x plus 12 with respect to x. All right, and that's for all this. So if we do that, we should get, I know it's going to be an x cubed because I'm starting from a square, so reverse power rule. Since I have that 3 as my exponent, 27 divided by that 3 gets me 9, so my lead coefficient should be a 9 there. I have a negative 1 x. That means I would have started with an x squared. That negative 1 divided by the power 2 means I would have had a negative 1 half. 12 integral of a constant, just that value, plus an x, or times an x, plus c, because we don't know what the specific value should be. Okay, so here's what we need to do. Now that I have this, this represents what f of x should be if I didn't have an extra piece of information, right? I know it needs to have the 9x cubed. I know it needs to have that negative 1 half x squared and a positive 12x plus some constant. Now I need to figure out exactly what that constant is. So let's go ahead and do some replacements. I should have 9 cubed minus 1 half squared plus 12 times plus c should equal, right? And I just update with the given information I have. 1, 1, 1, 17.5. So then as you're solving this, we see that on the left side, we have 9 minus a half plus 12 is 20 and a half plus c should equal 17 and a half, meaning that c should be a negative 3. Okay, so I think I have enough information to talk about the integral I found. So let's recap. Based off the fact that the derivative of lowercase f was 54x minus 12 and that lowercase f of 1 equaled 38, I was able to find that its integral for this particular solution should be a 27x squared minus x plus 12. And since I was tasked with finding capital f of x, that means that I had to go ahead and find the integral one more time. And by doing so, I found that I should have started with the 9x cubed minus a 1 half x squared plus a 12x. And based off the fact that I was given the coordinate point of 1 comma 17.5, I knew that the c value for this particular equation should be minus 3. So if you have to do it twice, just do it step at a time and update after every single one to find each particular solution. And that's pretty much all you have to do for tomorrow's lesson. Hope this helps.